Hi, hello everyone. Welcome to our webinar, our today's webinar. My name is Natalia. I'm a product manager here in SMARTTECH for Asian market, and this is my colleague. He will be here with us showing the technical part, like the most important part of
Good
a
morning,
3D
everybody.
scanning. Yeah, Karol, he is a technical manager in SMARTTECH. The main subject of our today's webinar, why color information is important in 3D scanning. I hope it will be very interesting for you all, especially that in the world of 3D scanning, the scanning with color is a significantly new subject, and a lot of people think that it can be applied only for artistic stuff or life science or museology. But interestingly enough, it is more and more often applied in industry and the heavy industry as well. That's why we here in the company seeing that tendencies of people being interested in color scanning like from everywhere, we decided to tell you a little bit more about it in a few short words, of course, and we will be showing you some examples also from the industrial point of views. A few words about our company. SMARTTECH is a Polish manufacturer, and here we are specializing with making 3D scanners with a structured light technology that allows metrological perfection and metrological systematics to register objects and their shapes and also their colors. In this subject, we are like world leader providing this color 3D scanning. Our company was founded in the year 2000, so we are over 20 years on the market already, and we are constantly working to improve our technology in like both in industrial and non-industrial application. We are very proud that we can offer the highest parameters professional devices for all of our customers, and we are trying to reach every market and every customer very individually. As we are a manufacturer, we are also proudly very flexible, talk with every customer and their need. We have all of our scanners have metrologically certified accuracy. And of course, as we grow from the university ourselves, and a lot like biggest part of our crew is from the university. Also, we really like to cooperate with universities, with institutions, educational institutes, also with the technology of ours. Our company constantly grows. Right now, we have our distributors in almost every continent all over the world, and we are constantly growing, reaching more and more markets. Few points that makes our 3D scanners unique is that first of all, what we are very proud of, we offer the highest resolution available on the market, both in our line scanning with color and the line scanning like the line dedicated for industry that do not register color. We offer detectors from 1.4 megapixels up to 24 megapixels for color scanning and 20 megapixels for stereo scanning. We created our own software to run with our devices. We really try, or we made it really user-friendly and also really efficient. So it calculates huge amount of data in a very short time. As you can see on the screen, we are using like really pretty regular laptops, and on the live part of the presentation you will see with Carol that it runs really smoothly. Our 3D scanners can capture the texture and the color. Every point of the point cloud has its own color with the RGB scale. As I mentioned, metrological certification is something that is very important and not that common among the producers of 3D scanners. And we also applied unique features like, for example, projection of a color map of deviation of the object. Carol will tell a little bit more about it a little later. As one of our main points, like show points, is our resolution. On the screen right now, you can see on the main screen, you can see that why the resolution is important. Both of those pictures were made with the scanner with the same accuracy. So the accuracy on the left and the right one are exactly the same, but the resolution is different. So the resolution on the left one is only 2 megapixels, when on the right one is 10 megapixels resolution camera that was capturing that image. And even if the accuracy is here exactly the same, you can clearly see that the visibility of the details is much worse. For people who were not working with 3D scanning before, I would like to highlight just a few main points why 3D scanning is really helpful and can be really can bring a lot for the businesses and for the projects that everyone can has. First of all, really high precision. The scanners can measure elements and objects with extremely precisely. And the accuracy can reach up to few microns. So for most of the projects, it's more than enough. And precision of such a level is pretty much impossible to reach with a traditional manual method of measurements. Measuring with scanners, especially with structured light scanners that we offer, is really fast. So you can work with like a huge amount of project really fast. The capturing of the image is like few seconds, and it is contactless measuring. So you put your object on the rotary stage or in front of the measuring device in front of the scanner, and basically it measures itself. It's very important when you have to work fast or you cannot touch the object, when we are talking about museology, for example. Because we focus that for our devices and software, for everything to be available for not only technical people. So it's very easy to work with, and also you can work like in a huge distance between each other. In a nowadays work, when we can work from few offices that are around the country, it's like really easy and really convenient to just send the data between each other that are very accurate. And the quality, of course, because we are the company, certified company, and we are a metrological company, the quality of our scanners and the quality of our scanning results is very important to us. All of our devices are certified, so you have assurance that the quality is always there. First, like I would like to divide the subject of our of our presentation on two sides. First, we have why color scanning can be very useful for industrial and technical applications. And the second leg will be why it is important for non-technical applications, like, as I mentioned, archaeology, museology, forensics, lastly, and so on. We will start from non-technical applications. And here we have a lot of applications that people are automatically think about when we are thinking about color 3D scanning. So first of all, accurate detailed documentation, and we are talking about documentation not only about dimensions, but also about the color, because the point cloud that we are capturing is really clean, like raw, right away from the process. You can easily see what is there, and the post-processing is not complicated and not that advanced, not needed to be that advanced, let's say, because the calculation itself inside the software is advanced, of course. But the data can be used for archival purposes as well, as the data don't have to be post-processed to be saved and to like show all the dimensions and shapes and carry all the informations. So we have that one, and then it became really important among museums like all over the world. And it's constantly growing and growing. That's first. Second, when you have documentation done that way, you can use it for creation, like online presentation, online exhibitions of the collection, any kind of collection that you can have. The collection can be published online, can be easily shared between scientists and people who are interested. And making the national heritage digital makes it very easy to access for people. And actually that's like one of the main purposes of having the collection and the museums. So this is the market that really is open for the 3D scanners. On the screen you can see two of many examples that we can share with you. One is from the National Museum of Prehistory in Taiwan. On the bottom you also have a link to, so you can just follow it and you will be able to reach this online exhibition. The collection is constantly during the process of capturing and like placing it online. So it can be really great. On the right, you have two examples of the collection from Taiwan, and it's pretty amazing that we are here far away and we can just admire the art from there. And the second example is from our region, from Poland. This is also those are figurines that were made in Mainz, and all the collection also is captured, even if the figurines are like small and handmade, so very detailed and darker. It's perfectly everything visible online. You can also follow the links and see it. Another application for like non-technical projects is using 3D scanners for complex conservation process and also reconstruction. When you have the documentation detailed that much and it is really easily to use the 3D model for other purposes. We've been doing few projects with conservation specialists So first of all, they get perfect documentation of the object. On the screen, you have a painting. Is a Polish is a painting we made in Poland, and what is a characteristic for the structured light technology, it is safe to use it on paintings and on painted surfaces that are like historic. So it's not a problem at all, and it captures not only the texture but every detail that is in paint. It is visible also, and then having that model with that kind of details, you can then post-process it and use it for then reconstruction process. If some part is missing, then you can just digitally check and modify the model, check what version will be the best suitable, and then just based on the model that you created digitally, calculate what do you have to do for how much you need to, I don't know, purchase some material to make a reconstruction. Another application, precise databases for online research, typically. This is something that is also becoming very popular, and it's linked to the first application, so digitizing the collection. But here, because our scanners are so precise and capture like all the details as they are, it is possible to make a model of some object. In this case, you can see on the screen, it was a collection of a human remains, also from Poland, from Brześć Kujawski. It is like north, and the collection is huge. So they digitize it, they placed it online on a page that is accessible for everybody for free, like basics are for free. And scientists all over the world can use it for their research. And a lot of papers already is on the website. Unfortunately, most of them in Polish, but it's growing. So hopefully it will not be for much longer only Polish, but based on the 3D models, because you can do research, you can do measurements, you can compare colors and stuff like that. Virtual cross sections are also possible. A lot of research to compare the skulls in this case were made, and a lot of interesting, very interesting informations are there. When you have 3D model already, you can use a 3D printer to print it out. And this is something that since the beginning of this year, we noticed is booming. So on the screen, you can see the remain that is called the vampire from Piotrków. The vampire because of the nail pierced through the skull. This was characteristic for vampire burials. But because the findings, such kind of findings are very rare, so people were very interested. But at the same time, the skull is really fragile. So the scientists made a 3D scan with our scanner, and they 3D printed it with color. And as you can see on the bottom right picture, the biggest one, this skull is 3D printed. It's not painted. It's just it is how it went out. So it's a great copy, and you can really easily travel with it, show it on the exhibitions, on the presentation for students, and so on and so on. And I would like to show you the video that we've made that explain a little bit more the 3D printing process. It is an open opportunity for a lot of people to like expand their use of 3D scanner as 3D printing becoming really popular. We've made it with our distributors in Taiwan, and we Okay, now you should see the video. I get in information that you couldn't see it. So few informations about our scanner. And we've made a copy of a figurine that is like really colorful. It's like archaeological part. It's from the museum, and it was like really amazingly beautiful. We've made a copy. We've made a 3D scan. It was a touchless process, so it was very easy for the museum to agree for that, and also they had a documentation. And here our distributors from Taiwan, they made it a 3D print out of the figurine. You can see the process now. It's pretty complicated. It's a little bit more complicated than I thought it will be. A lot of processes, let's say, a lot of steps, but the results, can you see on the screen? It's like breathtaking. It's amazing. The colors, the capturing of the color, the copy is like great. So I was amazed that even if the distance is really far, we could have or we could share the experience of working with an object in the 2 different continents. That was pretty great. Excuse me. So now we just really fastly brushed through the possibilities for non-industrial, non-technical applications. They are, of course, much more advanced. They can be, but just to give you a quick view of what you can do. Now we skip to our industrial applications, our technicals, the projects that we also made. First of all, the color scanner can be used for very advanced production lines. And so on the screen, you have an examples that we've made here in Poland, and we've been measuring the meat that was on the production line, and it was needed to know how much of the fat is in the meat to classify the meat. So we've made a scan on the production line of the meat, and with the color coding, we've been able to automatically highlight the parts of fat in the meat. And on the last picture from the top row, you see that only the fat parts are highlighted, and you can calculate the area that this fat is taken from the whole meat part. That makes the classification very easily and like technical. So it's not that someone is judging that this meat will be class A or B or something. It's just measured, so you are sure. On the bottom is the project that was even more focused on the color. I don't know if you can see it clearly, although on the bottom you have like a metal sheet, and it was corroded in the middle part. And to check the area that we need to repair, we have to calculate how much of a material we need to buy and replace. And it was impossible to check it otherwise than with color, because the color changed, nothing else, like on the first side. And with the color scanning, we made a model. We highlighted the colors that changed, and we've been able to calculate precisely where and how much of a material we have to change for repairing. Another technical application is easy prototyping. So especially when you produce very complicated shapes, you sometimes, like, especially when they are like 3D, so cups, everything, and they have some graphics on it, it can be very challenging to prototype something as the shapes changed when you like not when it's not flat anymore. So with especially when it's like reverse engineering. So when you have a cup that is decorated, here is an example that was like hand decorated. We've made a scan and then we digitally flattened the surface, so it was easy to see where the production line needs to place the decoration to make a copy of such object. Another application, complex quality control. This was a project that we've made in Poland also, and in a factory, in a chicken factory, there is also a classification of chicken legs, and one of the one of the points of classification is the color of the chicken. That's the significance, how much meat is on and stuff like that. So we've made a scan of a chicken leg, and it was possible to automatize the classification process and the quality control if all the legs that are coming out of the production line from such class are really this class. And of course, possibility to calculate volumes as well. Something that is really very intuitive with a 3D scanner with color. So design abilities when you have a 3D model is a little bit similar like with the reconstruction, but less, let's say, scientific and more creative. So when you have a shoe in this case, from our client, we made the scan, and they, having a 3D model, were able to first make detailed documentation and a virtual storage. So all the documentation about actually every detail of a shoes, the material, the shape, the design, everything is easily stored and safe and easily accessible. When you have few thousands or few millions of papers and of shapes to find, it is of course much easier when you have the most detailed and the most packed data easily accessible. And the second advantage was, with a model, the designers could work, and based on the model that was, let's say, bestseller, they could make another version using the 3D model, and few people from few different parts of the city could work on the same model, on the same project, creating the new design. Yeah, so now we are on the part when I will be passing the mic to Karol, and he will be showing you the live part of the presentation to prove all the things that I've been telling you about our software, about the technical of our scanning, so you will be able to see it live. So, Karol, the floor is yours.
Thank you, Natalia. So good morning, everybody, one more time. Today, I would like to give you an answer for the question, what can we get from the scanning with, from the 3D scanning with color? So maybe at first, I will show you our detail, which we are going to scan. So it is part of a gas turbine, and the most important thing in here is a scratch, which is almost invisible, which I will show you later. That is, it almost invisible on the geometry of object, but it is visible on the texture. Even if I'm touching it, I can't feel this. So maybe let's move on to our software. I will begin from the single scan. So just by clicking the start button, the software is giving the information to the scanner to capture the to project the measurement sequence on the object. For this unit, scanning process, capturing the data takes about 5 seconds, and later on it is the post-processing of the cloud of point, the calculating the geometry. The cloud of point which we are getting from our software is a raw cloud of points. There are no algorithms during the scanning, so it is how it looks like. So now you can see the results of scanning the single cloud of points. So when I zoom in, you can see millions of points for that scanner, which I'm using right now. It is almost 4 million of points visible. Sorry, 15 millions of points visible for that one single scan. So using our rotary stage, we can rotate part to the different angle to capture the geometry from the another side. One more time, I will click start button. On the camera, you can see that scanner is projecting fringes. It is our measurement sequence, and the detector is capturing the image of those fringes. And after a few seconds, we've got the results. So what exactly can we get from those scans? So at first, maybe let's wait for the result. Okay. So during the Natalia speech, I've made the triangle mesh from my scans, which I made at the beginning. And when we zoom in on that triangle mesh, we can see that there is nothing in this area. But I know by looking on the part that there is something. When I will turn on the texture of object, I can see exactly that here is the defect, the scratch on the object, which is only visible on the texture. So this is the view with the texture, and right now it is without the texture on the triangle mesh. So what more we can get from those scans is that gas flow shape. So using the RGB point selection algorithm, we can check how we can check the impact of the temperature and the gas flow on the surface of the object. So using that algorithm, I can, using the RGB values, select the places where I can see that there is something wrong, that are those are spots where the gas is flowing during the work of gas turbine. And what it helps us with making the fatigue test. So we can scan that gas turbine before working and after so many hours of work, and we can check how this impacted of the surface of the object and the material properties. So after selecting this, we can invert our selection. And after that, the result is just the point cloud of the gas oxide which are depositing on the surface. And using those scans, we can measure the area of this of these changes. So maybe one more time, I will show you the single cloud of point. So on that single scan, we can see millions of points. Each of points has their own XYZ position. And also we've got information about color in RGB scale. So maybe one more time, our triangle mesh without the texture, where we can't see our changes. And in here is triangle mesh with the color, with the texture, on where we can perfectly see where is our crack and the defect on the surface of the object. So I think that's everything for me. Thank you. And I give the voice back to the Natalia.
Thank you. So as you saw on this very interesting part of the presentation, the color, even if it's not really popular yet, but it's becoming one, can give you huge amount of information.
Yes,
okay.
We can see.
Great. So we actually reached the end of our short presentation. Just to sum up what we've told you up till now, as you saw, color 3D scanning can have a lot of application, such in non-industrial areas as in the industry as well. The most popular already in the museums and non-technical applications are digitalization, but of course a lot of more application of a 3D scanner is growing already. From archiving, prototyping, like conservation process for non-technical use, but 3D, because also 3D printing is becoming a very popular innovation among all such non-industrial as industrial applications. We can use the 3D model, the very precise 3D model, to like starting from making copies for the museum shops, what we've been working with through like sharing the information for a long distance, like working online also. So sending those data will be very, very easy, and it's easier when you have the object with you, when you can have all the measurements and all the details also with color in front of your eyes. Color 3D scanning becoming also very popular in the industries, as you saw on the presentation from Carol. It is really useful. Prototyping and designing is something that came to mind, but also very high-tech quality control, reverse engineering. All of that is possible with the color scanning. And when you have color scanner in your property or in your accessibility, because it impacts the speed of, for example, registering the defects that you have on a production line, the automatization of a quality control, and so on and so on. It also impacts the savings of the company. So this is a point that like beside the the possibility to grow the education, the research, it also can impact and will be impacting the growth of the industries, like in the same line as well. Thank you for your attention. I hope that the presentation was interesting for you. Of course, from both sides, industrial and non-industrial, you can have a lot of more examples and a lot of more use. As they say, sky is the limit. So with a very precise, detailed scanner, you can it's up to you. What do you want to use it for? And the possibilities are endless. Of course, if you will have some questions, we are open. Please type them down in the chat part of our meeting, and we will read them out and answer. And of course, if later on you will have any questions, you can reach me or you can reach Carol. Also, you can contact our company directly. So they will find us. The contact details you have on the screen. Do you have any questions? The chat bar is up the screen when you have the red button to like leave. So on the left, you have a little cloud, and when you will click on it, you will skip to the chat part of a presentation. And of course, if you prefer, you have my email and the phone, the WhatsApp contacts, for LinkedIn contacts for all of us. So
we've got one question.
We've got a question. How do you handle old articles without damaging it in museums? Well, I'm an archaeologist also, so I am professionally trained to do that. Also, when you are working in with a museum or with artifacts, you are not just entering there and working as you wish. Always some professional from the museum is with you, and usually they handle the objects. So we have rotary stage. You saw the bigger one today, and also we have a smaller one. They are automated. So we just place them on the table, and then carefully, like with the gloves, you transfer the object on the rotary stage. And when it's stabilized, we make sure it's just rotate by itself, and then you carefully give it back to the museum authorities.
Yes, I was a few times in the scanning in the museum, so there is always somebody from staff which is taking care of that object, and that person is putting the objects on the rotary stage, and we are sure that the object is not damaged. I can see that there's another question. Can we generate the report from our software, from this software related of the to the taken sample of any specific product? In our software, there is an option to make the quality control report. For example, we can import to our software CAD model, and after this, we can align the scanned data to the CAD model using the global alignment, 3:1 alignment, and the plane line point alignment. And after this, we can make the 3D compare. We can put the annotation of this and make the quick quality control report. Maybe I will find the report, and when Natalia will answer for the next question, I will show you something
Sure.
about this.
So the next question we have, can the 3D scanner be used outdoors? Yes, it can, although it is not recommended to use it on the direct sun, as the device is working by capturing the the light fringes. So when it's really harshly sunlight, it can impact the quality of the scans that you will get. So it is not impossible, although it is better to have at least a tent or something to make not a direct sun, but just by using the scanner outside, it is protected. We use carbon fiber housing and filters like dust filters and so on. So it is not termed for being dangerous for the scanner itself. But the quality on the direct sun can be a little worse. But as you see inside, now we have pretty good lighting, and we have like a light source right in front of us to make us better visible for you. So a lot of light bulbs everywhere, so it doesn't have to be dark. Although the sunlight is changing pretty fastly, so not recommended, but possible. And it was the second part of that question. The scanner needs to be fixed.
And yes, our scanners are the meteorological machines. So it means that it has to be stable during scanning. Those are not lasers, handheld scanners. With our devices, we can get the accuracy even up to 10 microns. So the device has to be placed stable on the cone stand like this, or on the normal tripod, like for the camera. There is also a function of checking the shock during the scanning. So if somebody bump the scanner with the hand, or that there's ground shaking on the plant, we can get the information that there was something wrong with our scan, and that you have to repeat this.
But it doesn't have to be like recalculate every time. So when you have some big objects and you want to move the scanner around, you don't have to calibrate it every time. So you just place the scanner, and then you can walk around it with it if it's necessary, without needed to recalibration, if that's what you've been asking for. How long does it take for 3D images to process?
Now, there are many things which impact on time of the scanning. So the first thing is the resolution of the detector. So from our range from 2 megapixels to 24 megapixels, the time can change in a very significant way. So for the 2 megapixels is from the capturing time for the single scan is from 0.2 seconds, and for the for example 18 megapixels detector, like in here, it is about 5-6 seconds for capturing the single scan. Then the next thing is the power of the computer, of the laptop. The data captured, every pixel has to be calculated, so it takes a little bit time to capture this. So for the standard part, which we can fit inside of the measurement volume, so the scanning takes about 2 or 3 minutes using the rotary stage, and then about from 15 to 20 minutes for the post-processing of object. In our software, we can also use the automation process, so we can make the macro script and programs step by step in easy way what we want to do. So we can add there the single scan, the rotary measurement scan, the rotary stage measurement scan, then some post-processing and the triangle mesh. So basically in easy way, we can make the automation from which by one mouse button we can make the full triangle mesh from the scanning to the watertight triangle mesh, which is textured and ready, for example, to 3D print.
What is the size of the file?
The size of the file depends of the number of data. It is it is hard to say. It depends on of how many points are there, but it is for the very big part. It is about 1 GB for our project. Yes, but this is the object about half a meter per half a meter scanned with the 18 megapixel detector. Yeah, our scanners in the housing has also on top of the scanner we can see that there are Hepa filters, which allow our scanners to work in the facilities or the areas where there is a lot of dust around of this. We can add extra ceilings in every weak spot of the scanner to reduce the impact of the dust for the scanning. This is and there is also possibility, yes, to have the special room for the scanner to scan in the sterile, in the clean environment. But there is possibility to scan with our scanners in the facility next to the production line, and many of our customers are doing this.
So answering the question, it is not needed for a separate room to operate. It can be if you want to have like a scanning room.
Yes.
It will be easier for sure, so everything will be just ready to go, but it's not necessary. You can just take your scanner and go to the room that you need it to be scanned.
There's also a question about the calibration of our system. So in the package with our scanner, there is a calibration matrix, which is used for refreshing the calibration of the scanner. For our customers, we recommend to make the recalibration twice per year. So if you are not traveling with the scanner, you don't have to make the recalibration very often. But when you travel, just to have the best possible quality, the accuracy of the scans, you need to have the recalibration. But in the normal way, when you've got your device on site and you are not traveling with this, you don't have to make the recalibration. For example, this scanner has not been recalibrated for about half a year, and everything is okay with this. Yesterday I checked this using the special ball bars to check the accuracy of the scanner, special artifacts, and everything was good. The accuracy was like half a year when I was doing the recalibration of the scanner.
We also had a question, how safe is to transfer data between offices? We do not transfer the data with our scanner, we just capture the data. So the safety of it depends on what you use. The data are like capturing by the scanner, and you can transform them with our software, although we don't send them. Like when you have two scanners or something, the transfer is not there. So you have to send it, and the safety of the data depends on what do you use. For all of the question about the cost of the devices, please reach me. I just noticed I didn't give you my email address on the screen. It is ns@smarttech3d.com. Although you can use Carol's email, and you just write the question and I will get it. Carol will transfer it. So all the question about the cost and about let's say purchasing process, please reach me individually, and we will discuss it as it is more complex, let's say, process. So I need to ask a few questions to establish how the process will look like.
How do scanners perform when compared to the blue light scanners? So for the main advantage of color scanners is that we can white light color scanners is that we can capture the color of the object. So we don't have only the geometry information like in the blue light scanners, but we can also capture the color. So that is the biggest difference. Maybe with the blue light scanners, the accuracy will be a little bit better, but there is no information about color.
What is the safety of the scanner for our bodies? You can use safely a scanner with a structured light technology on the bodies, also on the face. It is safe for the eyesight as well. We even have a line that is dedicated for medical use, so for capturing the human body and human faces. But with all of our scanners, you can easily do that. It's just like a looking on a light bulb, so it is safe.
For question, yeah, how the scanner score comparing to the Gomor card size? Yes, it is hard questions for the company which is producing the scanners. Yes, because our scanners are the best on the market. But to be honest, yes, every system has their own pros and cons. Yes, we are competing with the another companies.
We are successively competing with them, but it's as it's complicated system, the complicated technology. It's not that easy to answer, on a Q&A part of a webinar, as there are like a special presentation for that. We have a lot of points that are on our advantages. Some are on their sides, of course. So it is a point for a whole new presentation. When we are talking with our customers, and they are curious, we provide such a presentation, let's say, and we discuss it, but it's like for a very long time. For now, what I can say, we compete with both of those companies. We beat them in like there are cases that we win with them really easily, depending on what the customer needs. We think, of course, in the company that we are very competitive to them, and our scanners are really among the best on the best of the market. So yeah, a question is very complicated to easily answer.
Yeah, maybe it is better to ask that question to our customers, which give the trust for us and bought our devices.
We have few customers that switch companies to our, I think that you can, when you will find our customer, you can just ask. Can we scan modular kitchens or interiors of a building with them too? You can, but it will be time consuming, as it's because the high accuracy, the field of view of the scanner is pretty small comparing to the interior of the building. So as long as you do not stitch the structured light scanner with, let's say, photogrammetry, the hand stitching of each scan that you have to make with a field of view of our scanner to scan the entire interior of the building, it will be very time consuming. If you really want to, it's possible. If you need like 7 microns accuracy of the interior of the building, or for some designing reasons, for example, but you have to be prepared. It takes some time.
Okay, so if there are no more questions, I think that we can end our presentation.
Thank you very much for joining us. It was a pleasure to talk to you all in this end part of the presentation. Especially, I'm really thrilled that you are so interested in the presentation. I hope that you enjoyed it. We will reach you with some feedback afterwards. Of course, you can reach both of us also for more questions or just for a little chat later. Thank you very much again, and have a nice day.
Yes, thank you for your time and for all your questions. Have a good day and bye-bye.
Goodbye.